Alright, so what's left behind? 15 divided by 3 is? 3x cubed y divided by 3x. 6x squared divided by 3x. 12x divided by 3x. Remember, whatever you GCF out, you should be able to multiply back in and get to the original. So 3 times 4 gives 12x. Sure.
Is this so hard to do?
No. What we're going to do is we're going to look at 4 more examples. And today we're sticking to the easy factoring examples, which means that the a value is 1. So what do I mean by the a value is 1? Go back to standard form of a quadratic function. Standard form is ax squared plus bx plus c. So here's my a. In all the examples tonight that are factoring this way, all of the a's will be 1, unless you have a GCF in front of the number that you can pull out, making the a non-1. So, if you look at example 4, when you look at this example, what do we notice about the signs on this example? They're both positive, right? So, that means that this is the case of ax squared plus bx plus c. All positive quadratics will always factor as 2 positives, no matter what. If these are both positive, then these are both positive. Now, here's why we have the homework we had last night. So last night in your homework, you had 2 numbers here that multiplied to give you your number here.
Oh, is this going to be a log combination?
Added to get you this number here. Maybe, I'm not sure, I don't know that reference. So what we're going to do is we're going to put this number up top. So here's your 30. Your 30, and then the number here goes in the bottom. So what you have to do is you have to find multiples of 30, or factors of 30, that sum to 11. So it's like yesterday, but in reverse. Yesterday I gave you the numbers, you multiplied to get this, and added to get that. Now we have the multiple and we have the addition. I need this. So what 2 numbers multiply to give me? Awesome. So 5 and 6 multiply to give me 30 and add to 11. So that means as factors, this is x plus 5, x plus 6.
Okay, these the first 2.
Today. Not for this whole chapter, but today.
What about this class? Like, are we going to take a test that's going on this class?
Today is day 1. So, this problem is now ax squared minus bx plus c. So if you have a positive c, your factors have to be the same sign. So if you have a positive c, they're either both positive or both negative. The middle bx part tells me which way they go. So this is negative and this is positive, therefore they're both negative.
So what if they switch those plus 7 minus 10? Would it be plus?
It would be opposites, 1 plus 1 minus. If the back number is negative, then the signs are opposite. If the back number is positive, the signs are the same. I'll show you all 3 cases at the end.
Oh, okay, wait, so if it's plus 10 minutes, it's negative. Yeah, it's the same. But if it's minus 10,
They're opposite. Correct. So, fill in your magic X. The top number is what you multiply. The bottom number is what you add. So 2 numbers that multiply to give me a positive 10 and add add to give me a negative 7. And I know both numbers have to be negative because both of these are negative. Yeah. Very good. So negative 5 and negative 2 fill in my factors. Okay, one more that is different. So now, here's the case where I have a negative c value. If I have a negative c, that means that my signs are opposite. Exactly.
Does it matter which way it goes?
Nope. Where you're going to determine which one's positive and which one's negative is based off the factors and then this. So let's do my magic x. Negative 40 goes up top, and negative 3 goes at the bottom. So two numbers that add to give me negative 3 and multiply to give me negative 40.
85.
Okay. So here's, as I say, here's where you figure out the positives and the negatives. Since this is negative, I need the bottom number to be negative. So I need negative 8 and positive 5.
I'm working on that. And I bought something just so I get 2 points.
Wait, you get?
It matters which factor is positive and which one's negative. Because see how this is a negative 3? If I made this a positive 8 and not a negative 5, then I'd have got positive 3. So when you have this case, if this is negative, you pick the larger factor to be negative. If this was positive, I'd pick the larger number to be positive. So it all depends on what's happening here. And that's why the x is helpful, because if you added these together, you could see what happens with each case. All right, x squared plus x minus 12. So once again, this is a case where I have a negative c, so I know my signs have to be opposites. So fill in your magic x, negative 12, positive 1. There's no number, it's always a 1. Two factors of negative 12 that add up to positive 1. What do you think?
4 and negative 3.
Good. So a positive 4 and a negative 3 adding together give me positive 1 and multiply together to give me negative 12.
Gotcha.
So I get x plus 4, x minus 3. Okay, 4 more examples.
Yeah, that looks right.
So let's do our magic x's. So you could take these problems, put your x's down, and fill in all the magic x numbers to start. So what are factors of negative 6 that add together to give me negative 5?
Negative 6 and 1.
Very good. So the 6 has to be negative and the 1 has to be positive. So that means I have x minus 6, x plus 1. Factors of 16 that add to negative 8.
Would it be 4 and negative 4, or would it be both negatives?
Both have to be negative because the 16 is positive. So the only way to get a positive is a negative times a negative. So you have x minus 4, x minus 4. How about negative 60? So again, if this is a negative top number, one's negative and one's positive. So negative 60 and negative 7. What are some factors of 60? 5 and 12, or you could have said 6 and 10. But 5 and 12 are going to give me my negative 7. So since 7's negative, I want my 12 to be negative because it's the larger factor. So you get x minus 12, x plus 5. All right, this one's a little tricky. Factors Okay, your homework is on a worksheet. There are only 9 problems. I like the magic X's, so I know not all of you need them, but I would like to see them if you can, just for tonight.
Maybe you said please not. Oh.